All right, so let's take a look at this. I'm going to do the first one with you guys so you have it. You can write it down as notes on the page. You can always refer back to it tonight. Remember, the slope, according to the formula we've talked about, is the difference in y divided by the difference in x. So for number 1, I'm going to take the two y's, because remember it's x comma y, x comma y. So I'll do negative 9 minus 6, and then 10 minus 1. Watch your signs. So negative 9 minus 6 is negative 15. 10 minus 1 is 9. And that reduces, let's see, the 3 divides into each of them, negative 5/3. That's my final answer. You should always try to reduce the fractions. So don't leave them as a top-heavy fraction if you can avoid it. And it's just that formula. The good news, like I said, is that's about all we're going to hold you accountable for in this section. We're not going to push you much past that. Also, I can tell you, looking down the answer key, the majority of these are going to be fractions you have to reduce. They're not going to be neat and pretty decimals every time. I mean, pretty whole numbers for the slope. We got to get used to fractions. What can I say about this? About this?
I have a question.
Uh-huh.
Can we write it as a fraction and then still write it as a decimal?
If it makes you feel better, yeah, you can use your calculator to turn that into a decimal. But as we do things like do graphing and comparing, you're going to find it's more powerful to have the fraction available. Because I could look at this and say, I'm going to go up, I'm going to go down 5 and over 3 when I draw the graph. If I write out, let's see, this is 2.67. How do you graph 2.67 over 1? It's a little bit weirder, whereas this fraction of 5/3, I can actually look at it and say, okay, yeah, I'm going to go down 5, 1, 2, 3, 4, 5, over 3, 1, 2, 3, and I can keep going.
Alrighty.
So, just my advice. Other questions on this first one off the worksheet? Okay.